Alright, today I'm going to start talking about limits and affinity, and we'll go back and start thinking about some of those things that we've been doing earlier this year with limits. So the first thing I want to talk about is, how do you find a horizontal asymptote for a function? Well, horizontal asymptotes are found by finding the limit of the function as it approaches infinity and negative infinity. So what I have here on the screen is that if the limit as x approaches infinity of f of x equals L, so if this is the case, and then y equals L is the equation of the horizontal asymptote of f of x. Also, you need to check as the limit approaches negative infinity, if it equals L, then y equals L is the equation of the horizontal asymptote. Two reminders of the theorems that are involved with limits are these two. If you have two functions that are being added together, you can take the limits of them separately. If you have two functions that are being multiplied together, you can take the limits of those separately. Alright, so go ahead and start out. We're going to just do a couple examples, and I'm going to show you two ways of doing this. One of them is called L'Hopital's, and L'Hopital's is actually not normally taught early, but I feel like it's important and it saves a lot of time. But let's go ahead and do it what I consider to be the non-fast way without using L'Hopital's rule, which means if you're going to find the limit as x approaches infinity, the process that we're going to use is we're going to find the highest degree, which in this problem is a t, and we're going to divide. The highest degree is 1. T, the first, is what I should have said. And we're going to divide each term by that highest degree. So what I'm going to rewrite this as being is I'm going to divide this top part by t. On the bottom, I've got two things I'm going to divide by t. And I end up with this new limit. Really all I've done is divide by t everywhere, all three parts. I nearly forgot that one. After that, what we can do is we can simplify a little bit and rewrite this as 1 over 1 plus 1 over t. And now, using rules of limits, we can actually take the limit of each part separately. So the limit as x approaches infinity of 1 is just 1. The limit as x approaches infinity of 1 is 1. Plus, the limit as x approaches infinity of 1 over t is, now this is where you have to think a little bit. I've got t's here this whole time, and I've been talking about x's. I really should go back and make these t's. Let me do that really quick. I'm sorry I'm doing that in the middle of this video, but didn't realize I had that typo. But as t approaches infinity, this t value is going to get really, really large. So let's say it's 100,000. Well, 1 divided by 100,000 is a really, really, really small number. And as it keeps getting bigger and bigger and bigger, then maybe it's 1,000,000, it's getting closer and closer to 0. So I'm going to go ahead and say the limit as t approaches infinity of 1 over t is 0. What that means is that the limit as t approaches infinity of this function is 1. This would be its horizontal asymptote. This next example, or actually what I want to do now is talk about L'Hopital's rule before I move on to the next example. L'Hopital's rule basically just says and the highest degree, which is on the bottom. Get rid of everything else, and then we're just going to simplify. And so what ends up happening is you get t over t, which is 1. Look how much faster this method is than the other method. This is the method, L'Hopital's rule, that I will want you guys to use and that I encourage you to use. I'll do the next example on the next video.